Right, so the second short that we're going to talk about now that we've moved on from understanding let's just go back to that, what a normal distribution looks like, is to just go one step further. And if you remember, we discussed the concept of standard deviations. You remember we said that I remember I showed you a classroom with a number of grades, and you had many students you had the mean, and you had many students whose grades were very much close to the mean, and then you had some students whose grades were everywhere. And we wanted to understand, not only were we interested in the mean, but we were also interested in this data that was far away from the mean. And so we calculated we had the idea of the standard deviation, which looked at the average deviation the average deviation, if you like, of the data from the mean. Yes, how far on average is all the data from the mean? And we observe that when we look at a standard or a normal distribution, this isn't a very good one, but you can see where I'm going here. We observe, as we discussed, that if this is the mean, if we use the expression mu, right, that remember that the standard deviation was on average how far the data was from the mean. So we would get a standard deviation, and we can call this standard deviation. I'm just going to call this, I'm just going to use this expression here, this letter. Doesn't really matter. I'll just call this the standard deviation. Yes, so this will be the standard deviation. So it doesn't really matter. I could say my mean is 70 and my standard deviation is 5. Remember, it really is, well, 65 here, and I have here 75. So what this means is that my standard deviation is 5. Yes, I'll just change my pen color. What this means is that my standard deviation is on average 5 away from the mean going this way, or 5 away from the mean going this way. So it could be that I'm trying to sell something and the mean is £70. People on average are willing to pay £70. But when I observe the data, I'll get some 74s, I'll get some 72s, I'll get some 78s, I'll get some 68s, I'll get some 64s. And when I do the average of all of that, of all those distances away, that's 70. When I do the average of all those distances away from the mean, yes, I take the average of all those distances away from the mean and find the average of those distances, I get 5. And this is referred to as the first standard deviation, 5. Now, we observe, right, that with most normal distributions, that 68% of the data will fall in between these points, where we are one standard deviation away from the mean on this side and another standard deviation away from on this side. 68% of all the data. So whether we were looking at marks in a class, we were looking at heights of population, we were looking at weights of population, 68% of those people will be in this area here. That's the first point. Now we can look at a second standard deviation, which means, of course, means this will be 60, yes, and that means this will be 80. If I therefore take two standard deviations, right, because one standard deviation is 5, yes, so if I go 10 away from the mean both ways, I'll just change my pen color. We observe a different scenario. We observe that in all between two standard deviations going this way and two standard deviations going this way, that 95% of all the data will lie between 60 and 80, right? You can already sort of see it. A lot of this data, right, would of course lie between 60 and 80. We're saying 95% of that entire population will lie there. And that sort of makes sense, right? Because the closer it is to the mean, we will have less of that data. Now, by the way, just going back a little, let me just see if I can undo this. I can't. Let me just erase this again and just highlight something here. I suppose by default you can understand that if 68% of the data lies between the first standard deviation and the just between one standard deviation from the mean both ways. If this is 68%, you can accept that 34% lies here. Yes, and 34% lies here. That's what we're sort of saying. And in the same thinking, with the same thinking, we are saying that if this whole thing is 95%, therefore in this section here 47.5% of the data sits, and in this section here in dots 47.5 of the data sits. We can go one step further and look at 3 standard deviations. So 3 standard deviations would be 3 times 5, which is 15, and that'll take me all the way down to 55. Yes, 55, and I can look at that and look at 50, and here would be 85, and I can actually now observe. I'll just change my pen color again and use something different. Let's try this color and observe that from here all the way to here, so that's 3 standard deviations between 55 and 85. So 3 standard deviations either way, 99.8% or something along those lines lives, if you like, can be found within this. And that makes a bit more sense, of course. Again, that makes sense again, that of course, because we're pretty much getting close to all of the data, aren't we? In this population. So again, you can split that into 2, and half of that data would lie in this section of the curve, and the other half would lie in this section of the curve. So just to sort of tidy that up now, if I just erase all of that, I suppose I could just say, right, that when I have a mean, is I have the mean in the center, I could look, if you like, just at the standard deviations, and this, if you like, is 2 standard deviations away from the mean, 3 standard deviations away from the mean, and you can start to understand what's going on, because in the next video we're going to talk about some sort of normalization of this relationship. But the point here is that's my mean. I get my standard deviation, and I can subtract that standard deviation from the mean and get here at that standard deviation, and I can just multiply that, and I know that between here and here 68% of my data will lie, and of course between here and here 95% of my data. This is just general observation that we've just come to now accept, and we can, of course, we will see data to represent that. 95% of your data lives there, and between 3%, between 3 standard deviations either way, you will observe 3 standard deviations either way, you'll observe about a 99.8% confidence, if you like, that the data will lie in this space. Okay, that's the end of our second part of this discussion.